First of all, thank you, Geetam. Thank you, TEDx, for giving me opportunity to talk about Bharati, this novel script that we have developed here today. Let me begin with my story of how I got to the idea of making this new script. I'm not a linguist. I'm an electrical engineer by training, and now I'm an academic. My specialization is something called computational neuroscience, which deals with building mathematical and computational models of brain. We try to understand how brain works. It's quite interesting. And some of these ideas people are borrowing them from neuroscience to apply them to artificial engineering problems. For example, in pattern recognition, to see patterns in data. And one such problem is character recognition, where you try to understand characters automatically. For example, you might have seen on some mobiles, you can write with a stylus, and the software recognizes what you have written and shows them in fonts. So these kinds of softwares existed in English and other world languages for a long time. And about 10 years ago, there's been a big effort to make these kinds of softwares for Indian languages. I was also part of this kind of effort. And we worked on several scripts, like for Tamil, Telugu, Malayalam, Hindi, and so on. But over the period of time, I've been realizing that it's very hard to work with our languages, our scripts, because they're quite complicated. Then after struggling for a long time to get that commercial quality software, I decided I won't work with the scripts anymore, but I'll make my own script. Okay, it's like saying, you have taken 10 examinations, you have done very badly in all of them, then you decide, okay, I'll make my own question paper where I'll do very, very well. Okay, so that's what I've done, and that's how the Bharti was born. Okay, so Bharti is a novel script which has been proposed as a common script for Indian languages. India is a land of lots of languages, and we are quite proud of our linguistic heritage. There are 22 official languages. Each of these is spoken by tens of millions of people. And there are actually 652 minor languages, some of which are spoken by smaller communities having about tens of thousands of people. And these scripts are written in 11 major scripts, the other minor scripts, but I'm only talking about some of the major scripts. There are these 4 scripts used in the northern part of India. Hindi is written in Devanagari, then Punjabi is written in Gurmukhi, and Bengali and Assamese share kind of pretty much the same script. And then you have Gujarati. Then in the center, you have Oriya. In the south, you have 4 scripts, Telugu, Kannada, Tamil, and Malayalam. Then there is Urdu and English. These are used pretty much everywhere in India. At the current literacy rate of about 75%, nearly 900 million people in India are using these scripts. So you have many languages in India and many scripts. Interestingly, there is nearly a one-to-one correspondence between language and script. For example, Hindi is written in Devanagari, Telugu in Telugu, Kannada in Kannada, Gujarati in Gujarati. So there is that kind of a mapping between language and script. Doesn't have to be that way because language and script are independent entities. You can write many languages and many other scripts. For example, if you look at Western Europe, most Western European languages like English, French, German, Italian, and Spanish, they're all written in the same script, what's called the Roman script, or more popularly called the English script. So because we don't have a common script, when you go from place to place in India, you find the script barrier, especially if you want to read a street name, or the name of a city, or if you want to read, say, the names of destinations on buses, city buses, right, when you go to a new state, script becomes a barrier. And it's an unnecessary barrier for another reason, which is that most of our languages share a common stock of words from Sanskrit, right? So if that is the case, then why is script separating us? So let's take an example. So in addition to having lots of scripts in India, in each of these scripts, the writing systems are designed such that you have a very large number of characters. If you take English, you just have 26 characters. Even if you take uppercase and lowercase, you only have 52 characters. But if you look at a typical Indian language, like Hindi for example, you have order of 10,000 characters. Let me see how I got that figure. Let's take this example of the word tree. If you write this word in English, you just have S-T-R-E-E, which is just 5 characters. But if you write it in Hindi, you take this character called sa, you cut it into half, you get what's called half sa, and then you take ta, you cut it into half again, right? Then you take ra, and you morph it into kind of a stroke, right? You combine these 3 structures, and you construct this complex character called stri, no pun intended there. So basically what you're doing is, you are taking basic shapes and constructing more and more novel shapes in a combinatorial fashion. So therefore, typically in an Indian language, you end up with order of 10,000 characters. So that makes the scripts very complicated. So scripts are complicated, they're quite beautiful. these are some sample characters from various languages, but they can also be sometimes confusing. Here are some character pairs. So there you have Telugu character ra and ta, which are very dissimilar phonetically, but they look similar. So similarly, the Kannada character e and the vowel sound and similarly Tamil character I and ja So Devanagari, Sha and Pa, they're all very dissimilar sounds, but they look similar, and that can be confusing for an early learner. So with these considerations, I want to ask the question, can we come up with a common script across India? And it should be extremely simple script without all these complexities. The answer is yes. It's basically possible because the scripts lend themselves to a natural unification. 9 of the major scripts that we use in India today actually share a common phonetic structure. They all are saying the same thing, nearly, phonetically speaking, but only in visual appearance, they look different. Our scripts are organized very logically on phonetic basis by this great Indian scholar from 5th century BC called Panini. Unlike English, where the order of alphabets doesn't have any specific logic, I mean, at least not something that I know of. Why is A in the first place, why is B in the second place, and so on. But our scripts are arranged so that you first have vowels like A, E, and so on. Then you have consonants, there's Kaka, Gaga, and etc. And then you have consonant-vowel combinations, which we call Godintam in Telugu or Bharakadi in Hindi, where you take every consonant and combine it with every possible vowel. So you have Kaka, Kiki, and so on. And then you have more complex characters, like what are called consonant conjuncts, where you take, in a single character, you have multiple consonants, more than one consonant, and a vowel. So like, for example, Kra, Kra, Kri, Kri, and so on and so forth. So therefore, if you take a quick estimate of how many characters you end up with by this kind of a combination, let's say you have about 10 vowels, which is just a round figure, and there are about 30 consonants. Therefore, you have 30 times 10, 300 consonant-vowel combinations. If you take C, C, V type characters, you have 30 square times 10, that's 9,000. So very quickly, your number of characters runs into order of 10,000. Okay, so that is fine in itself, but the problem is the shape and the sound, they do not match perfectly in a lot of situations. So ideally speaking, in an ideal script, which is easy to learn, similar sounds should have similar shapes, and dissimilar sounds should have dissimilar shapes without any confusability. So can we derive a script, a novel script, in which this feature is achieved perfectly? So what exactly am I talking about? I mean, I'll ask a simple question to illustrate the concept. Now, who is the 47th Kaurava? Like, we know that Kauravas are this evil princes from of Kuru clan in Mahabharata. And Duryodhana is famous for his constant mustache twirling, and Dushasana is famous for his constant costume pulling, and so on. But otherwise, other guys like Dussaha, Dussala, Jalagandha, Sama, Saha, Vinda, Navinda. These guys, I mean, nobody knows these names. So if somebody asks you in a quiz, who is 47th Kaurava? You would draw a blank. But you would wonder how Gandhari and Dhritarashtra would have kept track of all their names of all their 100 sons. Suppose they named their sons on a simple basis like this: K1, K2, K3, K100. Right? 47th Kaurava is just K47. Okay? So I'm talking about something as simple as that. Can we come up with a script which is as simple and intuitive as that? So you don't have to really try to memorize the shapes of the characters. There are simple rules which use underlying phonetics and give you the shape of the character. So here I present Bharati vowels. So I'm using Telugu as a comparison, but you can do the comparison with any of the Indian languages, Indian scripts, there's 9 scripts. So in the black, you're seeing Telugu vowels, and in blue, you see Bharati vowels. So first of all, vowels are one specific family of characters, family of sounds. Therefore, by this rule that similar sounds should have similar shapes, all the vowels should kind of look similar, but actually that doesn't happen. I mean, look at the Telugu vowels, they all don't look like, there is no family resemblance. Whereas in Bharati, all the vowels share a common structure, that box-like structure which is open to the left side. Now you add little marks, what are called diacritics, on top of this box, and you get all the vowels. You can derive all the vowels. Okay, what is the basis of these markings? So let us look at the vowel sequence carefully. So they're all organized as a short vowel and then followed by a long vowel. You have a short vowel and a long vowel. Then again E short vowel, E long vowel. So look at how this sound, or this what is called dirgham, the prolongation of a vowel, is denoted graphically. Let's take A, and you take the end of it and twist it backwards, you get A. So now take E, and E have no resemblance. I don't even know how the creator of Telugu script has come up with long E from short E. Similarly, if you take U and you want to go to U, the horizontal line in the middle is stretched out and sort of curled upwards to get U. Right? Similarly, to go from A to A, you put this arc on top. To go from O to O, you put another kind of a hook on top. So to denote the same idea of a dirgham, a simple phonetic feature, that you are using some half a dozen different graphical conventions. That's what is making our scripts very complicated. Whereas, ideally speaking, if the script is designed on a very strict logical basis, you would use the same feature all the time to denote the idea of dirgham. So that's what we try to do in Bharati. So in Bharati, dirgham is always denoted by a horizontal line on top. So if you start with the letter A, which is that box-like structure, turn to the left. If you want A, you put this horizontal line on top. Now E is used, is denoted using that circle, little circle on top. Now if you want the long E, you just add that little horizontal tail to E. And you have U or U, which is obtained by adding the English letter U on top of A. And then you add this horizontal line to that U, you get U. Then you have R, then you have A. A you can see is a morphed version of kind of A ki matra in Hindi. Then long A is obtained by adding a horizontal bar again. And then I is again a morphed version of I ki matra in Hindi, the two horns, right? And then O is basically an inverted cup. And O is again, you attach a horizontal line. Then, O is horizontal line. And then O is the tilde-like structure on top of A. And then and Aha are inspired by Telugu and Kannada. You have these same kind of conventions. So that's how you construct the vowels in Bharati. Now let's go to consonants. Consonants are actually very interesting. There's a very interesting logic behind this organization. Consonants are grouped based on the articulation. That is how exactly do you shape your oral cavity or activate your vocal cords, right, to produce consonants. You see the first 25 consonants in our languages are in a 5 by 5 array, right? And there's a specific logic behind the horizontal, the rows and the vertical columns. The rows are organized by what is called the place of articulation. That is, when you utter these sounds, where in the oral cavity does your tongue touch? So for example, if you look at the first row of consonants, ka, ka, ga, ga, when you utter these sounds, a part of oral cavity called velum, which is way back in the oral cavity, is touched by your tongue. Therefore, these 5 characters are called velars. Similarly, when you utter cha, 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 right, you are touching the palate, which is at the roof of your oral cavity with your tongue. Or when you utter ta, ta, da, da, right, you are basically folding your tongue backwards, ta, right. Therefore, they are called retroflexes. And when you utter dentals, ta, ta, da, da, you are touching the teeth with your tongue. And when you utter pa, pa, ba, ba, these are called labials because you close your lips when you utter them. So there's very nice logical organization behind this kind of a grouping. Now, our letter shapes don't reflect this. You don't even know that all this is happening when you look at the shapes of these letters. Similarly, when you look at the columns, there's very interesting logic. Take the first column, kachata tapa, right? The second column is obtained by adding extra breadth of air to the first column characters. So if you want ka from ka, you're adding an extra breadth of air to that. This is called aspiration. Similarly, if you want to get ga from ka, right, you're activating your vocal cords, g, right, to get ga from ka. If you want to utter gha, you are basically adding both activation of vocal cords, which is called voicing and aspiration. So basically, you have two properties, aspiration and voicing. Okay, so it's like a binary code. You have 00, 01, 10, 11. So the shape of the character doesn't reflect any of this underlying phonetic logic. So if you design characters where the shape reflects this logic, it becomes very easy to remember them, remember these shapes. Then there are more consonants. You have yara, la, la, va, which are called the semi-vowels, and then you have sa, sha, and sha, which are called the sibilant because there's an S-like sound in them, and then you have whispers called ha. So now let's compare the Bharati consonants and Telugu consonants. In Bharati consonant, if you look at the first column, the first 5 of the first column, you have kachata tapa. You can very quickly notice that these are actually morphed and reduced, pruned from existing Indian characters. So ka is actually obtained from it's a pruned version of Hindi ka, and cha is also from Hindi. Ta is from Tamil because it's a very simple shape, and then ta is again from Hindi. Pa is from Tamil. So once you have the first 5 characters in the first column, right? So the second column denotes aspiration. So aspiration is denoted by adding a dot to the right bottom. So for all these characters, you just add dot to the right bottom. So similarly, voicing is denoted by adding a vertical bar to the left bottom. So for all these 5, you add a bar. So the fourth one, gha and so on, is constructed by adding both aspiration and voicing. So therefore, you add both the bar and the dot to all this. So with this logic, the first 20 consonants are trivial to remember, to understand why they are designed like that. Then the last column are called nasals, because these are the nasalized versions of the first column consonants. So then you have yara, lava. So now wherever there is no underlying pattern to the characters, I'm using English characters because English script is very, very popular, very common everywhere in India. La and la form a sequence. So la is again borrowed from Telugu and Kannada. And if you add a horizontal line below la, you get ala. Then there is an interesting sound called ra, which is there in Tamil and Malayalam. To construct this, add 2 bars below la, and then you get ra. So la, ala, and ra become a series. Similarly, if you take sa, sha, and sha, right, these again form a sequence. So the plain sa is English S, and then below that if you add 1 bar, you get this sa, and then below that if you add 2 bars, you get sha. Then ha again is actually a morphed version of Hindi ha. So that's how you construct the consonants. So once you have consonants, how do you construct the Bharakadi or Gunita? It's very simple. So take the consonant from this table and take the vowel that you want to combine it with from this table. So take this box and replace the box with the corresponding consonant, right? You get the consonant vowel combination, which is quite intuitive and simple. Okay, so this is the ka gunintam. So you take the ka and put all these same markings of vowels from the previous slide, and you get the full ka gunintam. So with this we can construct more words. So on the whole, you have a very small set of shapes which are used in Bharati. These are all the shapes that you use in Bharati. I just have kind of 18 slightly larger shapes and 20 small markings called diacritics. And by just combining these blocks, right, you can construct any character in any of these 9 languages. So some sample words from Hindi, Telugu, and Tamil, but you can do it for all in 9 languages, but I'm not showing examples here. Now, Bharati, like I said, was originally motivated by technology needs, right? And it's supposed to be a script that works very well with the machine, with the computer. So, and then I felt that it can also be used for regular use because it's very simple to learn. So one of the applications that you can think of is for mobiles, where when you try to write Indian language on mobiles, it doesn't work that well. But if you use Bharati as a text entry mechanism, you write your input in Bharati, output can be seen in any of the Indian languages. Can I have the video, please? So that is word Hindi, written in Bharati, and output is shown here. So it is ta, la, u, ga, u, gu, Telugu. All right, so we are changing the language, output language, and then writing a word from that language. The script is the same, but output language keeps changing. Output script keeps changing. Kannada, Malayalam. You can almost intuitively see why it is Malayalam, right? Malayalam. Bangla. Short break there. That's Gurmukhi. Okay. So then, similarly, even for OCR or optical character recognition, which has got to do with machine recognition of printed text, we expect to get high performance. We haven't developed that software yet. So basically, in OCR, you have to analyze the character and identify its various components and recognize the character. But since our characters are so complex, OCR is much harder to do with Indian languages, existing Indian scripts. But with Bharati, the way it is designed, all the component sounds are well segregated, well segmentable within the character image. So you should get much higher performance if you develop OCR systems in Bharati. So another study that we have done, my student has done with Bharati script, we found that it saves a lot of ink. So we compared Bharati with other 9 scripts, and we found that there's a huge savings in ink. And one potential complaint that people can make is that we already have so many scripts and we are struggling with them. It's so hard to learn new scripts. I mean, why do you offer us a new script, right? But then I want to say, how hard is it to learn Candy Crush Saga, right? Bharati is not any harder than that. It's actually even simpler than that. So here we're working with some local school children. Here a 10th class student is writing Tamil characters in Bharati. And we also made these kids write Tirukkural, which is a Tamil classic. And I know some students got 10 out of 10 on this, which they normally don't get in their native Tamil script. Okay, so it's very easy to learn. So in summary, Bharati, I hope it facilitates literacy because it's easy to learn, and literacy in India is abysmally low. And it facilitates migration across India because wherever you go, you see the same script and easy to read signboards and all that. It eliminates the script barrier that I was talking about. That was the original motivation. Also, another phenomenon that you notice in modern India is the next generation of Indians are walking away in a big way from Indian languages. So very often you find people are able to speak their mother tongues, but they're not able to write or read in their mother tongues. And partly the script poses a barrier for that kind of entry to Indian language literature or printed text in Indian languages. But if you have a simple script and a common script, and that barrier can be removed. It encourages tourism because it's easier to go to places and identify signs and all that. And you can save paint on signboards because right now on railway boards you find the same city name written in 3 or 4 scripts, and you can save paint if you use a single script and a simple script, and facilitate communication across the country. One example I can think of in Korea, in a few centuries ago, somebody decided that the existing Korean script, which is based on Chinese script, is too complicated. Let's design a simple script. And currently the Korean script is so simple that there are websites which say, learn Korean in 15 minutes. Okay, so Bharati is one such invention It's a very simple to learn, so hopefully people will take it up. Thank you very much. That's Vizag station in Bharati.